Good morning and good afternoon to you all. My name is Calvin Watkins. I'm a product manager at Gusmer Enterprises Incorporated based out of Fresno, California. I'd like to thank you all for coming, and I'd like to welcome you to our last webinar in our Hamilton series, Niche Applications for ORP Monitoring in the Brewing and Seltzer Market. This is, again, as I mentioned, our last webinar in our four-part series, and you can find all of our previous webinars, if you haven't seen those, at gusmerbeer.com. Today, we'll be going over a brief overview of the Gusmer and Hamilton companies and talking about our partnership together. We'll give you an introduction into the Hamilton's EasyFerm Plus ORP Arc sensor. We'll talk about the Arc Air software and how that you can interface with that sensor using your PC or your phone. Then we'll do a deep dive into ORP and look at sampling points in the beverage space and look at some of the applications on where you can use ORP in brewing. Throughout the presentation, if you have any questions, please feel free to use the Q&A function in Zoom. Go ahead and type those questions right in the Q&A chat, and we'll answer those at the end of the presentation. Just some background on Gusmer Enterprises. The company was founded in 1918, and we've adopted the motto "Service with Knowledge" since 1924. The company is family owned, and the management ownership is currently in its third generation. We have 5 locations, 2 in Northern California, 1 in Central Valley, Fresno, where I'm based out of. We also have a location in Waupaca, Wisconsin, and Mountainside, New Jersey. And our key and core markets are fermentation and filtration products and services for food, beverage, and biotech pharmaceutical. We are both a manufacturer and a distributor of resale products. We have 15 direct technical sales reps throughout the US, 4 product managers, 3 application specialists, and a total of 16 R&D scientists also throughout the US. After this presentation, if you happen to have additional questions or would like additional information, please feel free to reach out to us at gusmerenterprises.com. Click on the Find a Rep button at the top and type in your city and state, and you can be contacted with your local representative. Brief overview on Hamilton. So the Hamilton company, who we distribute for to the brewing industry in the US and Canada, they've been manufacturing precision measurement devices for over 60 years. We've had a partnership for nearly 7 years now. And again, we're Hamilton's sole distributor for the beverage industry across US and Canada. So I just wanted to get in to the ORP sensor specifically a little bit that we sell here at Gusmer. We sell the EasyFerm Plus ORP Arc. The Arc technology is great because you have an integrated transmitter inside of the sensor itself. You don't have to use an external transmitter. The ORP sensor specifically, you can connect digitally with RS-485, also known as Modbus, or you can use an analog 4 to 20 milliamp communication. The sensor has, again, a VP8. That means there's 8 pins on the sensor head there, so it's a VarioPin 8 connection. The sensor has a PG 13.5 thread that you can then thread into a housing and integrate into your process. There's a Bluetooth adapter also available that you can put onto the sensor head so that you can get a Bluetooth signal on your PC and your phone. The measurement range for this specific sensor is negative 1500 all the way up to positive 1500 millivolts. And we'll talk about that, what that means later in the presentation. You can also, what's great about the Bluetooth and the Arc Air software is you can log data over time. So if you want to do a study of how ORP looks like in your process over time. You can do a study up to 3 months. You can log data, so it's a great feature. Just a little bit of, again, some basics on how the sensor works. So the ORP electrode potential is the sum of 3 different potentials on the sensor. You have a platinum wire at the bottom. You also have a reference electrode sitting in some electrolyte there on the side of the sensor. And then you also have a junction between the electrolyte and what's in the process. So the reference is actually plus 220 millivolts. So when you read a 220 on your sensor, that's actually true 0 in your process. So if you're below 220, you're in a reductive state. If you're above 220, you're in a oxidative state, and we'll talk a little bit more about that later on. Calibration. So there's 2 different standards that we sell that Hamilton manufactures. All of Hamilton's calibration solutions are certified. They have an accuracy of plus minus 5 millivolts. They have a 2-year shelf life. And what's cool about these is that they have a unique bottle reservoir. You can kind of see that in the picture there, but you can dispense only as much buffer as you need at the top there, and then you can stick your probe in, calibrate it, and then you're not wasting solution, and you're not exposing that solution to air. So you're also avoiding cross-contamination. So again, only dispense what you need, and you're not wasting your buffer. You can calibrate the sensors very conveniently using the Arc Air software, and I'll talk about that in the next slide here. Sensor housings, spend a little bit of time on this, but the ORP sensors must be installed at a minimum of 15 degrees. So if you're installing the ORP in your process, you want the sensor to sit 15 degrees off of parallel to the floor. So the sensor can't be installed directly perpendicular into a tank. There has to be an offset so that that reference gel can sit at the bottom of your probe. So just FYI, we also sell triclover and varivent housings with a 15-degree angle. And those are PG 13.5. So you thread the sensor directly into the housing, and you can install it at an angle in your process. Arc Air. So this is Hamilton's user interface for the sensors. It's available on PC and also as a free download from the Apple and Android stores. On the software for free, you can read your sensors, you can calibrate your sensors, you can look at your errors and what you can look at your sensor health, your operating time. So it's a great piece of software, and again, you can do all this on your phone. On a PC, you're able to record data over time, like I mentioned earlier. For a fee, you can upgrade to the GMP compatible version of Arc Air. So if you have audits or traceability, if you want to use it for traceability, you can purchase the advanced version. On the software, you can monitor up to 30 sensors simultaneously. So ORP, DO, pH, multiple tanks, and again, you can use it to calibrate your sensors, configure them, troubleshoot them, and so forth. So this is kind of how the phone app looks. In this example, we're looking at a DO sensor. There's a couple warnings here. You'll get messages at the bottom there. We're just looking at the sensor health in the app. Sensor name is in the top right, and it's great because you can just get all this information on phone, tablet without having to log in. So on the PC. Bottom left, there's the three different configurations. So with that, I'd like to introduce Chris Webster. Chris is our technical sales representative out of the Pacific Northwest, and he will dive a little bit more deeply into the ORP concept and how we can apply that to brewing. So thanks for joining us, Chris.
Thanks, Calvin. As Calvin mentioned, my name is Chris Webster. I'm the technical representative with Gusmer Enterprises for the Pacific Northwest. I've been with the company for about 3 years now, and a little bit about my background. My background is really in biochemistry and microbiology, with particular focus in metabolism. In there, I also have a background in brewing and acted as a brewer as well as a QA manager for a brewing company. ORP, actually, before we get into ORP, maybe we should, highlight really what we hope to take away from this presentation. I'm going to try not to go too deep into the weeds. I'm going to try to keep it incredibly simple and not really focus on too much of the minutia. Really, the point here in this presentation is I want you to take away the operation of ORP and how you could potentially implement it into your process. Now, ORP is not a new concept. It's been used for decades across numerous industries, whether it's water quality, wastewater, bioprocessing. Different industries can utilize ORP for their benefit. In water quality, our wastewater, our municipalities use ORP to monitor the oxidative potential of the water that's in solution, that's in the plant. By augmenting that oxidative state, they can reduce the biological load that passes through the pipes and finds its way into your glass at your home. Additionally, some of us are fortunate enough to have swimming pools. Every now and then we need to do that chemical shock. Well, when we're doing that chemical shock, what we're really doing is driving up that ORP to prevent non-beneficial organisms or contaminating organisms from populating our swimming pools. In wastewater, ORP can be used to manage the breakdown of organic material that's in the sludge. But you can also use ORP to remediate toxins such as cyanide and hexavalent chromium that are really common byproducts from metal manufacturing. As we move into another industry of bioprocessing, ORP can be used to manage the biomass production or the yeast production in some of these tanks, and can optimize those fermentations for the production of things like industrialized enzymes, organic acids, solvents, as well as even things like vaccine production. More recently, in the wine industry, ORP's gotten quite popular. And that was really due to some studies that were done by Dr. Gordon Walker, as well as assistance with Hamilton at some high-end wineries in California. And what they were looking at was using ORP to manage fermentation and prevent those fermentations from going reductive. And reductive is a terminology that's used really commonly in winemaking and not so much in other industries. But what reduction means is the production of hydrogen sulfide, which is a stinky, eggy, sulfurous compound that occurs when ORP levels dip too low, or when your yeast are experiencing some form of reductive stress. And so really, we want to ask the question, what is ORP? Well, it stands for oxidation reduction potential. Throughout this talk, we'll kind of use the terminology ORP, oxidation reduction, and redox interchangeably, and they're really all into the same thing. Just want to bring it to your attention in case I jump between the terms. Oxidation reduction reactions are occurring in and around us every second of every day. They are the energetics that drive life and all the processes around us. If we think about when we sit down to a hearty meal, we grab that food and we're acting as primary oxidizers. We're taking that food, we're ingesting it into our stomachs, we're pulling all the electrons and energy equivalents off that food, oxidizing that food source, and collecting those reductive potentials. And we're taking those electrons and we're transferring them over into high energy bonds in the form of ATP. ATP we use to respire, we use ATP to have complex thinking, to operate our muscles, and even to lift a glass of beer to our lips. But this is not a perfect process. It's very prone to error, and those errors occur and they generate things like reactive oxygen species. So we've come to this conclusion that, hey, we can ingest things called antioxidants in our diet, like vitamin C, but our body also makes antioxidants endogenously in the form of glutathione. And these are really great at scavenging those reactive oxygen species. The reason why we want to do that is they're incredibly toxic to our DNA, and they can lead to mutation, and are a primary driver of aging process. For more of the physical world, some of us had probably had the unserendipitous luck of finding a rusty nail, perhaps through our shoe. A rusty nail is occurring because of a handful of systems that are in play. One is one is time, temperature, presence of oxygen, and a small amount of moisture can lead for the formation of this nasty oxide layer on the outside of an iron nail. So just transferring it basically from a shiny nail to this rusty one. And this process really isn't too different from what you experience in the brewing space every year when you do your cleaning programs throughout the brewery and repassivate your tanks. This is what you're really doing with those tanks when you're passivating them. You're generating an inert oxide layer so that your beer doesn't react with that tank. Next slide, please. So let's take a step back and look at the definition of what ORP is, or redox. And this is really the measure of the tendency of a substance to oxidize or reduce another substance. If we look to our left here, we see we have a reducing agent and we have an oxidizing agent. We see this electron moving from the reducing agent to the oxidizing agent. In doing so, that reducing agent becomes oxidized, and that oxidizing agent becomes reduced. If we kind of move this over to the right of the screen now, we can kind of see the interplay between these two fellas here. We have your reducing agent that's carrying that extra electron, and that oxidizing agent that really wants to steal it away. And so it steals that proverbial electron football from that reducing agent. Thus, that oxidizing agent becomes reduced, and the reducing agent becomes oxidized. We put them together in this fashion because it's really important to note that oxidation reduction reactions are coupled reactions. One does not occur without the other. They are always working in concert with one another. And one easy mnemonic to remember these oxidation reduction reactions is oil rig, or oxidation is losing electrons, reduction is gaining those electrons. Next slide, please. So as we move electrons around from substance to substance, it can be measured, and that potential can be measured. And now the point here isn't to really focus on exactly all the individual chemistries that are going on, but it's really to show that these half reactions generate a voltage, and that voltage is either a positive or negative number. So positive voltages refer to more oxidizing reactions or oxidizing chemicals, whereas those negative voltages are more based on those compounds that are tend to donate those electrons a little bit more. And so we can look at voltage or millivoltage from these potentials as being a way to monitor what's going on in certain systems using ORP measurement. Next slide. Now, beer chemistry is really incredibly complex. On the left here is a chart which is called a Van Crevelen diagram. What they're looking at, the researchers in this group did a cool study. They took 85 different world beers, not just from brewery to brewery, but from region to region and country to country. And they analyzed each and every one of them via mass spectrometry, and they generated what's called an atomic ratio. We're not going to get into the nuts and bolts of atomic ratios for this talk, but I think the really cool takeaway here is if you look at this mass spectrometry ratio schematic, those larger blobs of chemical compounds that are present across these different beer samples represent conserved compounds. That means the larger that compound is, or the larger that blob is, the more likely it's going to be conserved from beer style, from brewery to brewery. However, I think what's more striking is those little small minute points, those small points that are barely visible. There's literally thousands of them in this schematic. And this is showing the molecular complexity of beer from brewery to brewery, indicating that each of these little points are points of novelty from one beer to another. So you can use ORP, not necessarily to measure those individual points, but you can use ORP to monitor the overall chemistry of what's going on in your system, in your fermenter for your brewery, or even in your seltzery. By monitoring the ORP, we can improve the potential shelf stability of product. We know that there are a lot of beverage products out on the market. Some of those are very resistant to change over time in the cellar. Wine, for instance, has its improvement period, and then it hits its peak, and then it hits its eventual decline. Mead, which is honey wine, basically is said to never reach its peak. It's always improving. Things like scotch and other spirits tend to improve over time, but beer is an interesting one. It is really sensitive to degradation in flavor over time, generally leading to decreasing in bitterness, increasing in sweetness, and other oxidative cardboardy flavors can show up. Next slide. So if we were to kind of take a step back and think about fermentation, if we look to the left here, I've kind of indicated millivolts on the side of this graph, and this is just a brief understanding to show you where ORP can work in your process and what kind of information you can gain from it. So as we pitch yeast in the beginning of our alcoholic fermentation, we have high amounts of oxygen, denoted with the green line there. We have a high ORP. After all, oxidation reduction potential is measuring oxidative potential in that liquid, but we have a very low biomass. As fermentation moves forward, the yeast rapidly consume all that oxygen in a matter of hours. And in doing so, they lead to a steady decline in that oxidoreduction potential, or the redox potential on that red line there. Once the oxygen is depleted, the yeast need to quickly manage their metabolism. So they rearrange their metabolic programming so that they can leave that more aerobic state and be more functional in an anaerobic fermentative state. What you see on that, what's really kind of cool in this graph, is that you see that plateauing effect that's occurring with the ORP measure, and that's indicative of these yeast transitioning from that aerobic to more anaerobic, or state without oxygen metabolism. Once they've changed that programming, now the yeast become very efficient at sugar consumption, and they rapidly consume sugar, and they experience a logarithmic growth stage. In doing so, metabolic flux in the system really starts to move in one direction, and you drop that oxidoreductive potential, and you hit a minima. What's interesting, and I think a big takeaway on this graph, is that as ORP, or redox potential, hits a minima, your biomass is hitting a maxima. And as a brewer or seltzer manufacturer, you can take advantage of this. Next slide, please. So this is like, if we were to kind of get a brief idea based on what we've looked at from this previous slide, we're going to look at what happens at ORP as fermentation progresses. And really what you're seeing is at day one, you have a high amount of oxidants in suspension. So high amounts of oxygen, as well as your yeast are supplying an oxidative power, as well as, from my previous example of eating a burger or something, those yeast are functioning as oxidizers of those food sources. But you have very little product made. As the fermentation moves forward, we are consuming oxygen and increasing biomass. And eventually we come to an end state where fermentation is complete, and we have all those reactants and now just become products. This transition, or the movement through fermentation, can be tracked and monitored with ORP, and you can get a tangible measure in millivolts, something that you can use to improve your process. But another point to be made here is that as that as that beer progresses through fermentation, beer in this example, its molecular complexity increases, similar to that slide that we showed earlier. Next slide, please. So really, how do you measure this, and how do you do it in the real world setting? Well, Calvin did a really great job at explaining the anatomy of this probe. Okay, so this slide I think really does a great job at explaining what is happening with these measurements and how to do them properly. And I borrowed this slide from Steve Hammond over in with Hamilton. Basically, what you have is you have three solutions in this example. As you on the far left, you've got your reducing solution, which is, as we mentioned with the redox potentials, has a negative voltage, and highly oxidizing solution on the far right, which has a positive voltage. If we were to take an even mix of the two, you have what's called a balanced solution of redox, of oxidizers and reducers in even suspension. As you dip your probe into that initial, and let me actually, the typical ORP range that we're looking for is that -720 all the way up to 680 millivolts. As you take that probe and you dip it into that neutral solution, it has a net zero charge. However, the readout from the ORP probe is +220, and that's because you're looking at essentially the redox state of that reference cell, okay, which is a silver chloride electrode. As you move it to that more oxidizing solution, you let's say that's plus 680 millivolts. That ORP reading is going to be an additive response. So if you were to add 220 to 680 to account for that reference electrode, then the readout from the ORP probe would be 900 millivolts. And similarly, as we move over to these more reducing environments or reducing solutions, you have a -720 real value of that solution. However, the reference electrode compensated number is a -500 millivolts. And that's the direct readout from the ORP measure with the Hamilton probe. And I think it's really important to mention, as Calvin also did, is that you can see that +220 millivolt right in the center. And that is considered your true zero. Okay, so anything below +220 millivolts is really an indication that you're moving in more of a towards a more reducing solution. You know, throughout this webinar series, we've seen the reps and Calvin discuss all these different application points of Hamilton probes in the brewing process. For ORP, we're really only focused on two areas, and that's in the areas where yeast are actually multiplying. And so that's in the fermenter as well as in the yeast propagation systems. Next slide. So earlier when we discussed the varying industries that ORP is used in, we didn't really mention brewing, but it really is an important note that ORP, discussion to use ORP in brewing dates back well into the 30s. And here's a paper from the Siebel Institute that was published in the Industrial and Engineering Chemistry Journal back in the 1930s. What they were looking at is how to use ORP for brewing control. And now this idea and this concept was spot on. However, the technology just didn't exist for them to do this effectively. So really, why are the reasons that ORP has been mostly overlooked in the brewing and/or seltzer market? And that's really due to brewers have become incredibly adept at using other process parameters to improve their product. They use DO, pH adjustments of their mash, and then temperature control. And they can use these to a high degree to provide a very consistent, repeatable product. But it is important to mention they are in fact process parameters. Okay, ORP is simply another process parameter. In this case, with DO, pH, and temperature, ORP is reflected in each of those changes. Okay, so while brewers have not technically been using ORP as a direct measure, they have been monitoring ORP through the sum of some of these other process parameters. So as we move forward with our understanding of ORP, we kind of get into some of the application points where you as a brewer or seltzer manufacturer can really gain some insight. And ORP can be used in many of these niche applications, whether it be in beer or seltzer. Some of the big areas where you want to maybe focus is core brand and consistency. Your flagship brands are your bread and butter. They need to be produced consistently, day 1 through day 365 of the year. Any sway from consistency is going to lead to potential brand disloyalty in the marketplace. Using ORP gives you a real-time in the tank measure to see what's happening. How are your yeast behaving? How is the chemistry moving around in flux in this fermenter? They can also be used for R&D. We talked about the molecular complexities of beer in an earlier slide. But as you're doing research and development for new products and changing out your yeast, you can use ORP to gain new insights on how those yeasts are behaving in that mixture. By learning more from those processes, simply by using ORP, you can gain insight on scaling up that pilot batch all the way up to full production size. It goes without mention that ORP can be used to aid in yeast propagation and biomass production. We know this is in fact the case because this is why it's used a lot of time in bioprocessing and biopharmaceuticals. The net benefit of using ORP is allows you to monitor yeast health, allows you to monitor danger zones where fermentation or production of yeast cells, new yeast cells, is in a negative space or in a space that's not going to benefit the brewery. By improving the yeast health using ORP, you're also improving attenuation of that worked by those yeasts. That improved attenuation is going to lead to more product consistency. Batch to batch using those yeasts, they're going to perform more similar over time. But it's also going to have other benefits. It's going to allow you to produce consistent products for the marketplace, and as that brand develops, be able to generate a much greater following. We talked about reductive character control in wine, but this isn't typically an issue in brewing. And what that is, again, is this is H2S or hydrogen sulfide being produced during fermentations. And typically, hydrogen sulfide during a fermentation is generated when ORP levels are dipping and you have some level of nutrient stress. Sometimes that could be ultra low nutrition. Sometimes that could be ultra high nutrition. You can get some interesting chemistries that are going on. At the end of the day, no one wants to smell a rotten egg in their fermenter. Breweries don't really have to deal with this. Okay, you're using a wort that is loaded with high levels of free amino nitrogen. Okay, so they're generally never nitrogen deficient. However, in a seltzer, in this blank canvas of seltzer, you really have water, sugar, yeast, and maybe a little bit of nutrition, a little bit of nutrients in the form of nitrogen. Using ORP can help you understand your process. And by monitoring the low end of that ORP curve, you can optimize your yeast production, so you get better utilization of your sugars, but also it can tell you a little bit more about what's going on in terms of nutrition. If you're seeing reductive characters showing up very early, maybe you need to augment that fermentation with a little bit of oxygen, maybe some additional nitrogen. So another cool area, I think, where ORP is probably going to serve very important point in the brewing and seltzer space is in high gravity and very high gravity brewing of beer and seltzer. And we're talking about really high octane stuff here, okay? As you imagine, when the yeast is fermenting in a tank, or when you have a high gravity wort or wash or must for that matter, and you pitch your yeast into them, they experience an immediate osmotic stress. And in doing that, they kind of do some crazy morphological changes, both inside and outside of the cell, and they can generate some pretty crazy characters. By optimizing your fermentations with ORP, you can improve your yeast health so that they aren't so stressed out. By improving that yeast health, you can get more beneficial characters. We've all probably tried, or some people on this call have probably tried to brew a high gravity beer at some point. And like many, we've all experienced a stuck or sluggish fermentation. Oftentimes these stuck and sluggish fermentations can lead to either no ester production or too high of ester production, almost in the unpalatable range. So monitoring the ORP can give you a real-time monitor of those yeast, the health, and how they're dealing with the chemical environment that they're in, and allow you to augment that. So by improving the yeast health, you improve ester production, and it becomes more consistent from batch to batch, from brand to brand. Furthermore, as you're getting into these high gravity beers, I really encourage those brewers that haven't done this to think about it, because these are very niche products. And high gravity beers and products are generally thought to be more shelf stable. I mean, occasionally I'll go down into my cellar and I'll grab a pretty high gravity beer from one of my favorite producers, and I'll see how it's changed from year to year. And I'm always surprised how consistently good they taste. So by brewing high gravity, you grab a hold of an interesting niche marketplace for beer geeks, but also you're generating a generally more stable beer product. Probably one of the big application points for looking at doing high gravity or very high gravity beers and seltzers is by taking advantage of various economies of scale. By brewing, single turn of your brew house, and then using a de-aerated watering skid and a carbo blending skid, you can really expand your production capacity downstream of the fermenter. So this is on the cold end. By doing this, you increase many efficiencies throughout the brewery or the seltzer house for that matter. So I think it's really important to note that taking advantage of some of these economies can be really beneficial. We happen to supply these Denwell systems. They work fantastic, and talk to your rep if you're interested in learning a little bit more about those. Furthermore, as you blend these products down, you have the potential, if you will, to improve your product and your brand diversification. You can do this through implementation of various flavors and extracts. And we supply pure malt extracts, which are beer extracts that you can use to blend down a single primary product into multiple product streams, and thus diversifying your product portfolio. With this, you also, obviously we talked about some of the efficiency, but if you're really trying to grow your brand, using high gravity, implementing high gravity brewing in your process can also allow you to grow your core flagship brands by putting them through this process as well. By doing so, you're gonna decrease the number of turns of your brew house. You're gonna improve the efficiency of scheduling of your brew times with your team. It's gonna improve your labor costs, you decrease your waste. Obviously, fewer times that you have to turn your brew kettle, the more energy you're gonna save. And ultimately, the less vessels that you're using, the less cleaning chemicals and products that you're flushing down the drain. So these are all gonna benefit per unit of your product. Next slide. So why would you want to implement ORP in your process? Well, it is a real-time system of monitoring. okay, you can see yeast health in real time. Being able to see the yeast health in real time allows you to do real-time interventions. Imagine, if you will, you're brewing a high gravity hard seltzer. You know, if by monitoring ORP, you can see if you're moving into that dreadful minima of ORP, where your yeast are starting to decline in their health. So if you notice that you still have quite a bit of residual sugar in suspension and your fermentation is starting to drive towards that more reductive low-end minima in the redox state, you can take a real-time intervention with micro-oxygenation or perhaps nutrient additions to drive that baseline redox potential skyward, thus shifting that energy into healthy biomass production. By increasing that biomass and making it more healthy, you also decrease and control the off flavors that can be produced during the fermentation. And ultimately, you also improve their utilization of the sugars, leading to better attenuation and more consistency across your brand. So if I was to really want to implement a strategy in the brewery, I would say use ORP as a method to look at yeast propagation. Use it either in the fermenter or in the yeast propagation systems if you have one. Yeast is really quite expensive, and if you're replacing or repitching fresh yeast every couple of weeks, those numbers really add up. And so using these in your process to improve yeast health is going to also improve its repitchability and more consistent results from beer to beer, from brew to brew. On the hard seltzer end, you can use ORP to monitor the redox state of your fermentations and help dial in your nutrient additions and optimize your yeast health. So these are a couple of the reasons that I think that ORP can be used now in modern brewing and seltzer making. With that, I'll finish up and I'll welcome back Calvin and Jeff from Hamilton, and we'll be happy to take questions from here.
Sure. It says, wondering if you suggest using a portable ORP instead of an ORP meter physically mounted to a fermenter.
That's a great question. I think what's important is that the sensor be inserted into your process at least at a 15-degree angle, if not at a straight in. I don't know of any portable ORP devices in the market. However, you can take your ORP sensor, and if you're careful, you can manually take that from tank to tank and have it plugged into a USB power supply. For example, you could have it plugged into a cell phone charger, and that's enough to power the sensor, and then you can read that ORP value on your phone via the Bluetooth. However, again, I think what's critical is you'll have to insert the sensor at 15 degrees and have the ability to dismount and mount the sensor from tank to tank, or dip it in the top without damaging the sensor.
Calvin, can I add to that a little bit? I think the difference is if you want to spot check ORP, perhaps first trend is part of a process. So if you're checking from tank to tank and taking a spot check, that's great. If you want to actually say trend to fermentation process, as Chris was talking about, you would want to have the probe in the tank during the whole fermentation to be able to trend it and track it and optimize it. So it's sort of the difference between grab sample and continuous monitoring. And fortunately, there are ORP probes from Hamilton that cover both options. But I think really for the process optimization, you would want to have one immersed in the process during the run, if you guys agree.
I think another point to make there is that when you're doing these measures, you really want to be consistent about the depth to which these monitors or these probes are being held in your tank. These are typically more sensitive to oxygen than even an oxygen probe. They can really detect a lot of micro fluctuations that are going on in the chemistries of your tank. And so if you're not highly consistent or have your probe more close to the surface of the tank, where let's say if you're using an open fermenter in this example, then you would have much greater potential for oxygen ingress and much greater reactivity on that ORP probe versus sinking it in the bottom of the tank. So for consistency's sake, using an immersed probe at a fixed location in the tank is generally, I think, a process that you'd want to take if you're looking at tracking a brand or product over multiple days.
We have another question just coming in. It says, ballpark figure, how much do the ORP probes cost?
I'd suggest you contact your Gusmer rep and they can get you a quote pretty quickly on one for your process. There's a lot of options that you can choose, so they can do that pretty quickly.
That's correct. I'd say ballpark, you're looking at between 1,000 and 2,000 for a sensor and the housing and the setup. So, but again, as Jeff mentioned, contact your Gusmer rep.
Is fouling an issue? Yeast will settle out on the probe in an FV.
Yeah, in a fermentation vessel. Yeah, so you'll.
Yep.
It can be an issue. You definitely want to mount that sensor in a position where it's not going to be in the actual yeast bed at the bottom. Once the yeast flocculates and you have that bed of yeast at the bottom, you don't want it dipped in there. You do want it in a place in your fermenter where, as your fermentation processes and there's, that active fermentation in the beginning where there's agitation, that's okay. And that shouldn't be an issue because, as you have an active fermentation, you have movement in the tank. But once that active fermentation kind of dies down and you have very little agitation and there's not a lot of movement, you want to mount it in a spot where it's not going to be affected by gross solids. So I would say, just maybe a third way of the way up from the bottom or so. That's probably a good spot for it. You have anything to add, Jeff, possibly?
And depending upon the concern for the type of fouling in the manuals themselves, they'll cover whether it's buildup. For example, you can use isopropyl alcohol, for example, in a lab setting to clean it, or if it's calcium type stuff, there's nitric acid. So there's a whole set of instructions in the procedures within the manuals that you can reference as well for normal cleaning and care. And then obviously for each run, you'd want to spot check the calibration of the unit with the solutions, and then store it in a buffer solution between use.
We do sell. Hamilton has a maintenance kit as well, so you can maintain the life of your probe. I would, for regular use, I would suggest a maintenance probably every 4 weeks or so, every month, just to keep the probe in top shape. So, if possible, if you're going on a 3-month run and you're trying to collect data over a long period of time, that might not be feasible. But maintain the probe as best you can.
In some applications, particularly in some of the wineries where this equipment's installed, there are retractable housings and the sensors can be cleaned independently. There's a lot of fixturing solutions for the process. So, perhaps if you reach out to your Gusmer rep, that's a discussion point that you can have. And Hamilton has a full, complement of different types of options for housings and armatures and whatnot for a given application.
And it looks like that's all the questions, Kevin.
Great. Again, thank you all for joining us for this talk. Again, if you have any further questions that we couldn't answer, or if a question pops into your head later, please don't hesitate to go to gusmerenterprises.com, click on the Find a Rep button, type in your city and state and your industry, and your rep and his or her contact information will pop up there on the screen, and feel free to contact those reps. Thank you. Thank you for joining us. And we'll be posting this video on our gusmerbeer.com website later on in the week. Cheers.